Fantastic. And you're going to be talking to us today about career-oriented learning experience design. You're focused on designing curriculums for data analysis, and you're joining us from Springboard. So I'm looking forward to your talk. You have the stage.
All right. So good noon, everyone. Good day. I don't know which time zone you're joining, actually. I am not joining from the US. Currently, I'm actually joining in China, because of the COVID. So I was supposed to work in San Francisco office, but because of this situation this year, I'm staying here in a different time zone. So currently it's a bit, I would say crazy hours for me. It's like just past 12 midnight. So yeah, but anyway, I've adjusted myself to these crazy hours for the recent days, so it's okay for me. Today I'm glad to be here first, and the topic I'm going to share today is about career-oriented learning experience design, and I'm going to use our course as a case study. Before we dive in, a little bit about myself, about my background. So currently I am the senior instructional designer at Springboard. During my stay at the company for the past 2.5 years, I've created over 1,000 hours of content in both data science and UX design career tracks, which are two of our flagship products in our overall offerings. And in terms of my academic backgrounds, I hold 2 master's degree, one from Carnegie Mellon University and the other is from Vanderbilt University, both major in education. So you can tell from my background that I'm really dedicated to education. I just love education, and probably I will do education for the next 10 years or so in the future. And besides my work, I also have some areas of interest that I would like to explore. So for example, the e-learning design and how to use peer learning, and also how to use the learning science in theory and apply it in the real world. All right, so before I dive into today's topic, a little bit background about what the Springboard currently offering, because I think that would be helpful for the audience since we're using the course as an example. So overall, this is an online learning platform that we prepare the students to focus on the most in-demand careers in the industry, so like UX design, machine learning, software engineering, data science, and we the program that we provide is very comprehensive and mentor-led online learning programs. So I think this is an interesting topic, maybe for people from the business world as well as the academic world, because the way that we create course in our company is very career-oriented driven and user-driven. So that might be different from, how a course, for example, how a course is developed in a university or in a school. So I would like to call that there are 5 phases that we use, and we have actually verified it and implemented in almost all our course offerings. And it turns out that it's a good result. So I just want to share those phases to you all today. And hopefully, you can find there's any insight that you can apply even partial of the phases to your course build or your learning design phases in your work. So the first phase I want to share is we start any curriculum design by understanding the market needs. So what does that mean is, here is a little bit of interactive question that I want to ask the audience. Like if you look at the information on the slides, can you guess what is the job title that the information is about? So some hints here. This position has been aggressively promoted by most of the big tech companies, as you can name a few, and it is really well paid. You can see the salary range, and the roles and responsibilities are like such as like analyzing business results, transforming data, building experimental frameworks, and automate data collection. So I'll just pause here a little bit. And once you get an answer in your mind, I will review what the role it is. So it is data scientist. Someone in the chat says chief data officer. So that could also be possible, but this is like very high level role. Like since our program is training for the entry level role, I would say any chief data officer would start from a data scientist at the beginning. In terms of data scientists, I want to also call it that how big the market is and why we choose data science as one of our offerings is because we find out data, like a big data market is growing so rapidly, and also in a few years, it is expected to reach over $100 billion. And also based on Glassdoor and linking all sorts of websites, they have ranked data science as a top jobs or like the top emerging job reports. So that's because of all these reasons that we choose data science as one of the domains that we're going to train the future employees so they can feed the increasing market needs. And so once we decide, okay, data science is the place we're going. So what do we mean when we say we're building course for data science? And then we need to look deeper, like one level deeper down, right? Like we look at the data science hierarchy and then see, okay, what are the roles specific in this job family? And then it turns out that there are people in different like titles. They are all under the data science pyramid, but they are specialized in different jobs which need different kinds of skills that they need to be good at. So today I'm going to talk about data scientists and data analysts, this circled area. But also we do have other offerings, like we have data engineering track, we have like machine learning track. But today this is like the focus that I'm diving into. Yeah, so as I told, like data science is one of the areas that I choose this because I built this course. So my colleagues, they also build other courses, but I don't have a strong say about their course, but at least I know that what this course is about. So overall, this is very extensive. It is project-based learning. It has over 500 hours of a mix of curated and plus the in-house created curriculum. So usually the student will spend 6 to 9 months to complete the whole course. And we also teach like data science method, which is like a trendy process that they can do any jobs in the data scientist role. And we also provide them 3 specializations, business insider, generalist, and advanced machine learning to give them those flexibility to choose which track they want to go into. And also above that, we also have weekly one-on-one mentor calls and additional human support to facilitate all this process, because learning for 6 to 9 months is really, I would say is really hard, and it can be really lonely. So the student usually need more human support to complete this process. So, okay, now we understand the market needs, the market size, and the market job family. So what's the next step? The next step is we identify what are the skills that currently the universities offer or the students have, and then what's the gap between the student expectation and what the employers or the market needs. So here is an interesting research shows that university degrees, I'm just voicing over here, like university degrees almost never match the speed at which the data science field evolves. Textbooks and courses are not built depending on employers' current and emerging preferences. So what does that mean is if you look at the like the gray columns here, like what enterprises lack, you can see like, for example, big data management is like the top one skill set the employers they are looking for. However, it doesn't exist in what the current university is offering or what the students think they should learn. So apparently there is a huge skill gap or understanding of the huge gap exists in this market that need us to fill out the gap. So once we identify that, okay, there's a skill gap, then how to bridge the gap? Basically, seeing like how we can bridge the gap through building a course. So what, as an instructional designer, what we usually did is we did extensive like hiring manager interviews. So we, because we know that this is career driven, so we know that hiring manager should have the insights about what they need and what the candidate should possess as a strong candidate. So one example is, okay, I go ahead and I interview a hiring manager in a data science team at Airbnb. And then she gave me this 3 different tracks. And then she said, okay, in the Airbnb data science team, we have these 3 different roles. They are all data scientists, but they have different responsibilities and they usually require different key skills. So this is really interesting that neither the university or the candidate would possess this knowledge, but only it exists in the company or the hiring manager's head. So our job is to dig out this insight and make it into some actionable learning plans. So based on that, we also create like a kind of map to compare these 3 roles and then trying to understand, okay, if we break down the skills into, there are 2 buckets here, like technical skills and non-technical skills, what are the difference among each specializations, and that could help us to develop more focus or specialization for students who say want to go to the business track instead of the machine learning track. So for example, one thing we find out is for the business track students, business sense and let's say data visualization. So those skills are really like a must-have skills and they should be really strong at if they want to be a business-oriented data scientist. However, if they want to mostly apply for like a machine learning oriented data scientist, then they don't need to possess those strong skills. However, their machine learning and their math statistics and software engineering, those skills should be very important, and they should have really strong skills like that. And then after that, we start to building the skills, and we are trying to first, we're trying to find the connections of the skills. Like, okay, we have this list of skills. How would the skills structure and how would they come together as, if we're building a course, and what are the like level 1 skills and what are the like the second layer of skills and third layer. So we build this kind of a tree-shaped skill map for the data science, and also we highlight those are the skills that only needed for the business side and business insider, and those are the skills only needed for the machine learning, to differentiate like what are the skills we will teach differently in each specialization. And then we finally, after all this identification, this understanding, now we are moving on to the course design outline and goal. So I want to pause here a little bit, and then I want to say, like, most people, like outside the industry design, instructional design and learning design industry, they think as an instructional designer or learning designers, we just take the request and then we create the content and we deliver the content, and then that job is done. But this is not actually that simple as people thought, because all this preparation work, all this like identifying the needs and also restructuring the skills, those are like the really, really important foundations. Otherwise, you just spend time wasting time on building the content, which the users or the market don't need. So in this step, I'm pretty sure like a lot of people here are familiar with the backward design frameworks. So yes, we also use this framework to design, to guide our course design process. And we start with the red circle here, which is learning outcomes. And when we say learning outcomes, we mean like we define the end goal, and we define the learning objectives for the unit and sub-unit level, and we have the assessment plan, and we have the finally the course outline. But a course outline, we are also heavily rely on the feedback from the industry. So we have the advisory board, who are usually hiring managers who are expert in the industry, to give us feedback. So we iterate based on their feedback and finalize the course outline. And I just want to voicing over the end goal for this data science course. So the goal that we're trying to achieve is to equip students with essential skills as entry-level data scientists, and best position them. Okay, I'm not going to read all of them, but the goal that we're going to achieve is we want to train them to be the entry-level data scientists. So maybe the ultimate goal is it will be someday into the chief data officer. But you know, as the entry level, it is already like not a low-hanging fruit for them, and they need very, very hard work to get there in 6 to 9 months. And also they would we will help them to construct a portfolio which contains capstones, and also they will learn they will gain the proficiency in an end-to-end data science process. So those are the combinations of the end goal. And the course outline, I'm showing it a very, very high level. So I don't want to dive details into what the course outline look like, because that would be messy and too details. But basically from the data science process, we start from problem framing to data collection and data wrangling, and then exploratory data analysis, in-depth analysis, and then data storytelling. So we will use this structure as the course, like a skeleton, and then we'll build content, build learning activities and assessment around these. So the fourth step is develop the curriculum. So you can see here, like we have done a lot of work before we actually start to develop the content. And I'm not going to like explain like what LMS or what tools that we use. I think it depends on like people and organization, and it's not something very interesting based on this topic we are talking about today. So I would like to share maybe several I would say best practices that we apply learning science like series and into the content building and into our pedagogical design, and then it actually out like as an output as a final product. So one example is we use active learning. So I'm pretty sure like everyone here knows active learning, and we know that the retention rate will increase with the interaction with peers, teaching peers, and also do hands-on project. So in this course, we are heavily relying on the hands-on learning. Actually, more than 50% of the curriculum are hands-on learning projects. Like we have interactive like coding exercise, we have projects, we have cases, labs, and capstone portfolios. So overall, like our project are also based on like real world business scenarios. Like I think one of the cases also about COVID, but we developed like 2 years ago, so we didn't like correctly foresee the severeness of that COVID. But anyway, these cases are all built on the real world business scenarios. And then the second best practice is called segmenting. So segmenting is one of the 12 principles based on Richard Mayer's 12 multimedia instruction principles. So it refers to present learning user-based segments, not as continuous units. So what does that mean when we look at our course content building process. So it means that, as I said before, our course is a mix of curated plus in-house created content. So in some cases, like we need to find some good, for example, online lectures. I think this one is from Harvard X. So they have these really good materials, but the material is like 3 to 5 hours long. What we can do here is we still use the lecture, but then we chunk it up into 3 parts, and each part would paired with 10 minutes quiz. So the student can like instantly check their knowledge retention, as well as having a brain break, and then move on to the next section. And then the third best practice is called scaffolding. So it's meaning like we provide the support for learners to ensure the succeed in a learning environment. By the example here is previously I mentioned we have several capstone projects, but however, we're realizing that capstone project can be really intimidating for students who start a course and don't know, for example, which projects they're going to do and what data set they were going to choose. So it's too flexible for them. So we create this guided capstone, which is like they introduce in early in the curriculum, like this is unit 6. They're still in month 1 of the course, and this focus more on the data science like process instead of focusing on advanced technical skills like how to code in Python, how to do data wrangling like in Jupyter Notebook. So so this way we create them like a similar environment for them to understand the process instead of diving deep into solving the technical skills. And then lastly, but not the least, is personalization. So personalization has been, several examples, but here is just one example, which is we use like a quiz to help the student make decisions on what specialization they want to choose. So for example, they start a quiz and then they go through like 8 to 10 questions, and then it's like a black box, and then it outputs our recommendation is, okay, we think you are suitable for this business insider track. Inside that there are some algorithms, but the student don't need to know. They just need some help to make the decisions. And this is how the personalization is used in this course. Okay, and then the last phase in this learning design process is validate outcomes. So when I say validate outcome, it means when we launch the course, because this is one of our core product offerings, so we need to monitor the course quality, and in order to update it and then also fix the problems in time if this has been a blocker for students. So there are some success metrics we use to use as measuring the course quality. For example, we have activation rate, we have cancellation rate, we have like unit, subunit ratings, and we have qualitative feedback from students and mentors. We have some early completion rate, like we set up 7% as an indicator of early completion rate, and then the final completion rate, and there are more. But overall, for example, this graph here, this is interesting because this graph here showing how we validate how actually it's input from students. So students give us ratings on 3 dimensions: clarity, cohesiveness, and confidence. And then we transfer this into a visualized graph to track which subunit has more problems than the others. So the instructional designers, we can look into that specific subunit and fix as early as possible. Yeah, so I think that's it. Yeah, that's my last slide. Thank you for joining, and thank you for hearing this sharing. If you have any questions, you can reach out to me at this email, or you can reach out to me through LinkedIn.
Thank you very much. That was very interesting. If anyone has any questions, if they can put them into the Q&A box or the chat, and I'll get started with a question of my own.
Sure.
So the people who join the course, what sort of backgrounds have they typically done a university course in the area, or what would it usually be?
Yeah, that's a good question, because we this is such a big challenge for students. Like some students, they are even full-time employees, and it takes like 6 to 9 months. And also, you know, a lot of our topics are really sounds fancy, but also it's very hard, like machine learning, data science. So we do select people through admission process. We have some minimum bar for the student who apply for our programs. Like we ask them to fill out their background, like, are you a college graduate? Are you like, do you have like experience using any coding languages, etc. And we also have, we call it admission test. So we have this coding questions, although some students, they're really terrified by, you know, like being coding at the entry point of this course. Like they come to the course to learn coding, right? But we do want to know their levels of technical skills at first. And sometimes, yes, we do fail students. Like we think they are not qualified or they're not ready to take this advanced level of course. And the way that the method we do is we actually introduce them to a prep course, or we introduce them to, remember the funnel that I talked about, the hierarchy, that we have different courses. So if data science is too, let's see where it is. So if data science is too advanced, then we move down to data analyst, which we have usually less technical requirements for the students.
Yeah, okay, yeah, interesting. But for those who are quite technically advanced, what you're perhaps offering then is rounding out their skills and making them more ready for the job market and that you've identified.
Sorry, yeah.
So for those who come with quite a lot of technical skills already, what you're doing is filling in the gaps that you've identified in the job market so that those people can more easily get jobs.
Right. So usually students come into the course not fully prepared. If they are prepared, they will not come into our course. So they have very strong motivation to find a job. So that's actually one of the biggest advantage. The kind of boot camp has a much higher completion rate than, let's say, MOOC platforms. Like I think the completion rate is like less than 10%, versus usually the bootcamp completion is like over 50%. So of course, we help them to fill the gaps. I think one thing we are not able to do yet is to identify personalized gap. Like if the student is good at statistics, can they skip the statistic part, and then the total length of the curriculum would be less, like maybe from 6 months to 5 months. So that is the level that ideally we're trying to do, but we are still in the middle of exploring how to do that. So all students, either they take, for example, data analyst track or data scientist track or machine learning engineer track, but they cannot skip any of the units. If they're already good at that, then probably they can move faster and they can do this project much easier, but we require them to complete like 100% of the projects.
Thank you. That was really interesting, and thank you very much for joining us.